Thank you for being there. We are now joining the next session. It's always a difficult session. It's the section or the oral session before lunchtime, but we will be fast on this and we will be efficient. So let's go to the first. We have here the first presentation is development of new bio-based stimulants to improve the production of pine resin for the valorization of the pine sector. Quite a title. So I will share some data from the presenter, Inês. So Inês is currently a PhD student in chemistry at the University of Aveiro, whose main objective of work is the development of new stimulants, formulations of natural origin for the extraction of pine resin, as well as the valorization of this extractive through the investigation of new applications. The floor is yours. Welcome.
Thank you so much for your introduction. As you heard, I'm Inês. I'm a PhD student in chemistry, and I'm here today to talk about new bio-based stimulants to improve the production of pine resin for the valorization of the pine sector. This presentation is divided into a short introduction where topics such as resin, its extraction, production, and some applications will be addressed. The methodology that we are using to combat the problem that I will be present, and of course some results and respective conclusions. As you can imagine, the resin will be the key to all this work and can be obtained from gymnospermic species of the genus Pinus. In Portugal, the most common species are Pinus pinaster, known as maritime pine, and Pinus pinea, known as stone pine. Of the two, the one that we are using to extraction of the resin is Pinus pinaster. And the resin is viscose and translucid liquid compound with a minority fraction, the turpentine. This is a volatile fraction with alpha and beta pinene as a principal compounds, and the non-volatile fraction, about 80% of the rosin, with abietic acid as a principal compound. These two fractions is obtained in the first industrial transformation. After that, it goes to the second transformation industry, where it is subject to a several processing process to later be used in some diverse applications that I represent here. For example, depilatory wax, rubbers, perfumes, adhesives, pharmaceuticals, paints, or even cleaning products and food. The extraction process can be divided into several steps. Firstly, we need to remove the excess of the bark in the pine tree. After that, the incision is made. Then the bag to collection the resin is applied. And finally, the stimulant paste in the incision is applied. And this last step will be the most important step for all this work. And the question is, why do we need to apply a stimulant in the incision? So, pine trees produce resin in the living epithelial cells that surround the resinifer channels. And when they are exposed to an external aggressions, they start secreting resin as a defense mechanism. So, however, when this resin is exposed to the air, start crystallizing and will close the resinifer channels, and by applying the stimulant paste, we will delay the closure of the resin channels and extend the resin secretion. The problem is the stimulant paste currently used is based on sulfuric acid. and presents many risks to the environment and to the health of the resin workers. So, to combat these problems, we have developed a new class of bio-based stimulants to increase the resin production in pine trees. The methods that we are using to do this are based on natural eutectic mixtures. To prepare these formulations, we use eutectic solvents as a principal compound with a hydrogen bond acceptors, for example, choline chloride and betaine, and hydrogen bond donors like lactic acid, oxalic acid, among others that I represent here. Besides that, we also use some additives, for example, methyl ions, phytohormones, and water and ethylene glycol to optimize the viscosity and the production of these formulations. To test these formulations, we're using a microtapping process in adult pines. This procedure consists do a perforation in the tree. In this perforation, the application of the stimulant is applied. In this case, our eutectic mixtures, always at the same time as a control, that will be the sulfuric acid-based paste. Finally, a tube to collection of the resin is applied to calculate the production resin yields for each formulation and compare to the sulfuric acid productions. Initially, we tested four different formulations with different hydrogen bond donors, with emphasis to the formulation based on choline chloride and oxalic acid, with productions around 5 times higher compared to the sulfuric acid-based paste in just 24 hours, and 3 times higher in 168 hours. And this will be our selected formulation at start point. And our selected formulation needs to be optimized in terms of the application. In other words, we need to optimize this formulation to fix in the pine tree. So, to do this, we tested different molar ratios and the addition of compounds like ethylene glycol. These two formulations was the best in terms of the application, okay? But as you can see in the graphic, the productions was not the best when we compare it with sulfuric acid based paste. So we need to be optimized these two formulations in terms of the production. So to do this, we tested the addition of some compounds, for example, methyl ions in different concentrations, and some phytohormones. And as you can see, these two formulations, remember, was the formulations that we optimized in terms of the viscosity, with ferrous ion, have really high productions compared with sulfuric acid-based paste. In just 96 hours, we have productions around 3 times higher compared to the sulfuric acid-based paste. So we get it, two formulations with good applicability and good productions. Besides that, the resin obtained with our formulations and with sulfuric acid-based paste was analyzed with gas chromatographic, and as you can see, the chromatographic profiles obtained for each one, this is just one example, are very similar, namely in regard to the main components identified components of industrial interest identified. So, to conclude, the present study demonstrated that semiotic mixtures-based formulations are highly potential as alternatives to the sulfuric acid-based paste, in addition to being safer and cheaper. Besides that, the GCMES analysis demonstrated that the chemical composition of the resin obtained of sulfuric acid-based paste and our formulations is similar, thus being perfectly suitable for subsequent industrial processing. To finish my presentation, I'd like to say that the technical article was published in the magazine Resine. A patent was submitted as well as a scientific paper. This work has been presented in several competitions where it won 3 awards. So thank you so much for your attention.
Thank you, Inês. Nice presentation. Please take note of your questions. In the end of the section, we will have a time for Q&A. So I will move forward for the next presentation. It's the production of non-wovens from eucalyptus fibers and cotton fiber from textile waste, and it will be presented by Raquel Bértolo. Raquel? Okay, I will read something about her. Raquel holds a PhD in chemical engineering from Instituto Superior Técnico. In 2018, he joined REIS, where she has held various positions in the tissue area. She is currently an R&D specialist in tissue paper at REIS. She has published in several international journals in the fields of catalysis, cellulosic fibers, and tissue paper. The floor is yours. Welcome.
Thank you for your presentation. I will present you the production of nonwovens from eucalyptus fibers and cotton fibers from textile waste in collaboration with CTEV. The integration of recycled materials, including the recycled cotton, is a growing topic of interest and is a key driver to the circular sustainable. So despite the global focus on sustainable, the recycled cotton represents only about 1% of total cotton production in 2023. And this textile recycling is mainly mechanical and producing fibers that are often too short for new arms. So alternative application for these fibers are needed. On the other way, the production nonwovens from bleached eucalyptus kraft pulp presents a challenge, but also offer an opportunity, mainly when combined with other type of fibers. So one promising strategy is to blend the cotton waste fibers with wood pulp fibers, like eucalyptus pulp, to produce, in this case, wet-laid nonwovens. The main aims of your study was develop and characterize nonwoven structure produced by wet-laid technology from 100% bleached eucalyptus kraft pulp and 100% cotton waste, such as in the small pieces and recycled cotton fibers, and blends the eucalyptus pulp with the cotton waste. The materials used in this work is the post-industrial blue cotton waste provided by a Portuguese textile company and bleached eucalyptus kraft pulp from the Portuguese pulp mill. The cotton samples were produced in the 2 steps. The first one is the cotton textile waste cut into the cotton in small pieces, and then turn to the fibers, cotton fibers. The next step is the 2 samples were submitted to pre-extraction with water at 40 degrees during 12 hours, and finally the samples were refined in the standard laboratory valley refiner. The eucalyptus pulp suspension was prepared. The first step is the hydrated, disintegrated, and diluted, and the 3 materials is diluted and form the suspension of these fibers. The non-woven structure were produced by in the conventional sheet former in laboratory scale, following an adaptation of ISO standard. Had a basis weight in 20 grams per square meter, and different compositions were studied. 100% unrefined eucalyptus pulp, 100% of refined eucalyptus pulp, and 100% of the cotton in small pieces and recycled cotton fibers, and the blends with these materials. The cotton waste was characterized in terms of lag, tensile strength, and elongation, and the non-woven materials were characterized in terms of basis weight, thickness and bulk, and mechanical properties, softness, and moist management. And we analyzed the biometric properties of cotton fibers suspensions too. And the lag distribution results show that the cotton waste used contains a high proportion of small fibers, lower than 24 millimeters. And the mechanical properties, it's similar in these 2 samples, in the small pieces and recycled cotton fibers. The biometric properties show that the cotton in the small pieces had a higher content of fines, which help fill the void space between fibers and then provide interfibers bonding. The refined cotton fibers show the higher coarseness, and this property contributed to extruder with higher bulk and softness. And both cotton samples show the high curl, and in the hand of the analysis of these results, the presence of fines in cotton small pieces can mitigate the impact of the curl on the tensile index, and leading to improved the mechanical performance compared to the recycled cotton fibers. In terms of the physical and mechanical properties for cotton waste and unrefined eucalyptus pulp blends, the results show that the bulk and softness were higher for 100% of unrefined eucalyptus pulp, but these properties decreased when blended with cotton waste fiber. The mechanical properties increased when cotton waste and one unrefined eucalyptus pulp. In blends with cotton small pieces. And the softness was higher in the blends contain the recycled cotton fibers. The physical and mechanical properties with cotton waste and refined eucalyptus pulp blends, the results show it that the bulk was higher in nonwovens produced from cotton waste blended with refined eucalyptus pulp when compared to unrefined eucalyptus bulk. And the mechanical properties improved when using cotton in small pieces, and the softness was higher in the recycled cotton fiber blends. Comparing the refining eucalyptus pulp with unrefined eucalyptus pulp, the first one, the mechanical properties is more higher. The microscopy analysis of the nonwovens structures show that the nonwovens with 100% of eucalyptus pulp show the fibers more strength, and the cotton waste nonwovens are more curled, and this property is benefit for the porosity and the bonding between fibers. So, and the last two pictures, you can see the eucalyptus pulp contribute to improve the homogeneous structures and the uniform structures due to the interaction between cotton fiber and eucalyptus fibers. And this graph shows the top and bottom wetting time and top and bottom absorption rate, and the results show that all nonwovens were very hydrophilic, and the absorption rate is above 60% in all structures, and the absorption capacity was good, and the waiting time occurred in the 2 seconds. So, in conclusion, the blends with unrefined eucalyptus pulp and cotton waste fiber show higher mechanical properties. Comparing with 100% unrefined eucalyptus pulp nonwovens, the blending refined eucalyptus pulp with cotton waste increase mechanical properties and improve the softness when compared with when refined eucalyptus pulp nonwovens. Using cotton in small pieces appears more promising than recycled cotton fibers, offering better mechanical properties and require fewer processing steps. And the refining process of eucalyptus pulp appears to slightly decrease the overall moisture management, but it's the same occurs when recycled cotton fibers are used. This work, this approach highlights the potential of the combining cotton, textile waste and eucalyptus fibers to develop innovative materials based on the natural fibers, while contributing the sustainable of the textile industry. For future work, the application of films and chemical treatments can be explored to achieve specific properties according to their final application, such as lampshades, water repellent, superabsorption materials, and other recycled fiber search from textile manufacturing can be studied too. This work was carried out under the BIT project, promoted by the Recovery and Resilient Plan, and I would like to thank all team and your partner for their contribution.
Thank you, Inês. Nice presentation. Raquel, sorry. I will pay something for that. Okay, let's move on. So, next presentation, the title is What if we could transform industrial effluent into fresh water? I hope you did. So, presenters are Filipa, Moura and Joana Baldaia, and I will read something about them. Filipa is a process engineer at the Navigator company, where he made the management and coordination of products of water efficient and saving in the paper mill. She is also involved in the development of new products of packaging and the analysis and interpretation of process data and budget. Joana, you have a very big resume here, but I will read something about it. Joana is a process manager for strategic projects in the area of pulp production, water, and effluent treatment. And she is responsible for planning, resource allocation, budget control, and management of the conceptual, pre-engineering, and so on. Okay, welcome both. So the floor is yours.
Hello everyone. We'd like to start to thank you all for being here and to thank you Tecnicelpa for this opportunity. So first of all, the question that you have to keep in mind during this presentation is, what if you can turn waste into crystal clear water? The presentation is divided into 5 main topics. Project motivation, solutions to address water effluent challenges, follow-up on the performance of the implemented solutions, wastewater clarified water reuse challenges, and future steps. Okay, so regarding the project motivation, we have these 6 topics. That the first one is the navigator strategy that is aligned with sustainability and resilience goals. The water stress that we are all facing, especially here in Portugal, and the Suarium of Sado. The licensing that is increasing regulatory pressure on water permits, process optimization, and a new policy brief from the European Commission. Just to position the navigator and in terms of consumption of fresh water, we have here a benchmark from many industries. This is from 2024. And at the moment, navigator mill PM3 are around 50 cubic meters per ton, and PM4 it's around 9 cubic meters per ton. With the solutions that we are going to show you and the trials that we did, we were possible to position ourselves with the PM4 at 7 cubic meters per ton and PM3 at 11 cubic meters per ton.
Bom dia a todos. Good morning, everyone. As Mr. João Martins said, my name is Joana Baldaia, and I'm the project manager of the wastewater treatment plant retrofit and effluent reuse projects. So I'm going to introduce you the main motivations of the retrofit project and the industrial context behind this transformation. So the first motivation is the production of brown packaging paper in our paper mill number 1 in Setúbal, still with lignin, which increase the organic load and the color of the effluent. So with our old system, SBR technology, reached its limits, both on hydraulic capacity and also in the organic load removal. The second motivation, but the most important one, is to guarantee the environmental limits because at the same time we knew that a new license would soon be introduced at this time in 2021 when we started with the study of this project, but the values were not still defined in 2021, so we had to simulate and predict with our crystal ball the design criteria in order to study this project with the main suppliers. And the last motivation we have here is the restrictive water use in this complex. So in Setúbal mill we have 2 wastewater treatment plants. The wastewater treatment plant number 1 is for pulp mill effluent and the effluent of the paper machine number 4. So we have the privilege to have a dedicated wastewater treatment plant only for paper production. And then with this configuration we have the opportunity to optimize the quality of the effluent and then reuse in the paper machines. My colleague Filipa will share with you some results of the reuse of this permeate in the paper machine number 3, but also the directly clarify the water, in the paper machine number 4. Here, some short contexts. We select the membrane bioreactor technology with Veolia, and is the first paper unit in the world with the characteristics similar to our paper mill number 1 in Setúbal. And the installation of this technology permits a reduction of more than 90% in COD compared to values prior to the project. And then, with this permeate, we started an industrial trial in order to reuse 30 cubic meters per hour of permeates in our paper machine number 3. So here, just an overview of the old and the actual system. So the old system was a primary treatment and a biological treatment. This biological treatment was SBR, sequencing batch reactors, so a discontinuous process. And the core of this project was converting this SBR, this discontinuous process, into a continuous process, integrating both activated sludge system with this physical barrier with membranes ultrafiltration. So this project costs around 80 million euros, and the execution time was around 15 months. The first equipment we installed here is between the feed tank and the NEWS biological reactors, the fine screens. And the fine screens are able to remove the large particles in order to protect the membranes. In the aeration tanks, so we convert from SBRs to MBRs, to biological reactors, sorry, and we installed new aerators in order to guarantee the biological activity on these biological reactors. And then a completely new tank where we installed the membrane, the ultrafiltration membranes. Also to highlight that there are two chemical dosing systems with citric acid and sodium hypochlorite in order to remove organic and inorganic materials and prevent the accumulation of these materials on the surface of the membranes. Here, just more details regarding to the membrane bioreactor system. So, in this tank we have 5 lines. Each line is equipped with 5 cassettes of membranes, and each cassette of membranes has 1,300 models of membranes, and each model of membranes has around 10,000 membranes. We have also one spare in each line for future expansion if needed. And just to understand the operation mode of this MBR, I have here one membrane I will share with you, so you can try to visualize. The permeate inside this membrane and only pass water, ions, and low molecular compounds, weight compounds. And the external part of the membrane retains the bacteria and also the solids. So in each line we have one permeate pump. So the permeate is extracted from the membrane by vacuum action. We have one recirculation pump because, as I said before, this technology works with a combination between activated sludge circuits and membranes ultrafiltration. So we have a recirculation with activated sludge. We have also back pulse equipment. This back pulse equipment is used to wash the membranes with permeate. And then we have the chemical dosing systems for maintenance and recovery cleaning. Also, we have 6 blowers to have aeration at the base of the membranes. And this is an important detail because we will prevent the sculling and falling of the membranes with this fiber movement with this aeration. Okay. And then, so the plant performance after the retrofit. We would like to have with us some samples, but was not possible this week. So we have this picture here. The first picture is our crystal clear effluent, as you can see. It's the effluent that we discharge on the Sado River. The second one is the effluent at the inlet of the membrane tank. So it's a mixture between activated sludge and effluent. And we have another sample, is not here, but could be brown, if we are producing brown paper at the inlet of the wastewater treatment plant, or white if you are producing white paper. And here, just pay attention to this table. So this is the results of our crystal ball in 2021. So the design criteria that we shared with the main suppliers. And as you can see, the new license in green, it's higher than our best educated guesses. So the performance, just one comment, the performance of the plant is around 95% of efficiency in COD removal, and the color is always below 255 milligrams per liter. And with these results, we started to think, why not turning wastewater into fresh water? And then we started with this industrial trial. So we did this 3D model, just a temporary circuit until today. But we are working in transform it in a permanent one. So we install some hoses and a old pump from other installation, and we started to recover and reuse around 30 cubic meters per hour of permeate in the cooling waters of the paper machine number 3, and Filipa will show the results with you in the next slides. And just to see here some results, you can analyze this table, but we have this 2023 number, 19 cubic meters per ton, when we intensified the brown paper production. So we used a lot of fresh water in this type of production. And then we installed this temporary installation in 2024 in October, and the value is lower than the prior to this temporary installation. And then in 2025 we have our best performance value with 11 cubic meters per ton.
Just for you to have some view where we are putting this permeate, this is our pages from our DCS in PM3. And the permeate is being injected on the tank of the cooling water, and then this circuit goes right into the line from fresh water and goes to the condensates, AVAX, and sealing waters. Okay, so keep in mind, when we start to think to use the effluents on the paper machine, we have a question, because we are now doing packaging paper, and we have some food contact certificates that we have to apply. So we start to think, okay, what analysis that we have to do to make this possible? So we contact a specialist on REIS, Patricia Portela, that helped us to figure it out, what type of analysis, what type of certificates that we need to make this possible. So you made a giant list of all type of analysis. This is some of them. We have process, metals, and then others. As you know, for example, the PFAs are very critical for food contact, okay? And then we decide to compare, okay, let's try to compare the effluent with the most washed waters that we have on the machine. In this case is the clarified waters from PM3. Then when we received the results, we could observe that all the parameters were fine, were good to start the trial. But on the process level, we had some concerns with the chlorides and the calcium. So this was two main things that we should monitor during all the trial until it finished. So here we have the values that we had and control on our headbox quality white waters, mostly calcium, alkalinity, and conductivity, because this can show how the system is concentrating and how the amount of chlorides could be impacting on the paper quality and the runnability of the machine. That was something that we were concerned as well. But how you can see, we have before the trial and after the trial, the values were more or less all the same, on the same scale. One more thing that we monitoring during the trial, but is not here representing, it was the conductivity on the cooling water, and I can say to you that it was around 100 points above that when we start the trial, but we talked with our supplier and everything was under control, nothing very much preoccupant for us. In the next graphic, you can see the consumption before and during the trial. This represents a reduction between 70% to 25% of the consumption of fresh water on PM3. So now passing to another machine, PM4. As my colleague has said, Joana, we are very lucky to have MBR just dedicated to our paper mill number 1, but unfortunately on PM4 the effluent is mixed with the pulp effluent. However, we try to understand how we can reduce the water in the PM4. And, okay, we try to think, okay, let's try to use the clarified waters that we have on PM4 and try to wash our pulp with that water. So we started gradually. We start with only 8%, the ratio between fresh water and clarified waters. And then we go to increasing to 50%, 70%, and final 100% of clarified water washing the pulp coming from the pulp mill. This impact on the reduction of the fresh water on the paper machine and also in the fresh water used on the pulp mill. So was a win-win for both mills. So this provides us a way to pass to 9 cubic meters per ton of consumption to 7 cubic meters per ton of consumption on PM4. This represents as well, in terms of the effluent, we were able to reduce the effluent to the MBR plant 1 around 3 cubic hectometers per year. So, as we know, and some things I have already shared with you and Joana as well, the wastewater use has many challenges. One of them is a closed-loop water use system. The higher risk of MBR membrane fouling and scaling, and we are hoping that we are going to go further and reuse more of this effluent, and maybe we are studying this reverse osmosis, but then we have the concentrate disposal as a challenge as well.
Okay, so finally we are in the last slide, and regarding to the future works, we are focused on increase the permeate reuse in the paper mill, number 1, but also in the pulp mill. So we have a new project. This is in the last final analysis and financial analysis step, and this new project will permit to reuse around 100 cubic meters per hour in paper mill number 1, 200 cubic meters per hour in pulp mill, and then 100 cubic meters per hour in reverse osmosis in order to produce water comparing to fresh water. And based on investment value, operating costs, and in specific case of Setúbal, where we have some underground wells, we estimate some benefits around 1 million a year. So it's not a question of product diversification or environmental limits or water use strategy. Is also about a project with good financial parameter numbers. But still, we know that in our industry, in paper and pulp industry, water has no measurable value. So thank you, obrigada a todos. And now you know that no project is made with only 2 persons. So we would like to call to join us Isabel Pinto and Luís Machado from RAIZ, our program coordinators, and also Margarida Rocha, our process engineer from Recovery and Energy area. Please join us. And thank you.
When they do that, give an applause to them already, because they deserve it, for sure.
Sorry.
Okay.
Just one more thing. We like to thank 3 persons especially that support us through this process and believe in us in our work. So our compliment goes to Carlos Braz, Paulo Barata e António Sequeira. Obrigada.
Okay, thank you. I'm sure we are in the path to buy bottled water from Setúbal Mill of Navigator. So when you see it on the market, please remember that you have heard the first presentation of that new product. Okay, let's move on. So the next presentation is, I will say the title, is Revolutionizing Industrial Cooling, VEOLIA'S Cooling Horizon 2030 Program Drives Sustainable Water Management and the Ecological Transformation. The presenter will be Liliana Correia, and I will say a few words about her. Liliana is technical lead for the cooling circuit treatment segment in Iberia, lead product application, cooling, and value delivery coordinator for Iberia. She has more than 20 years of experience in industrial wastewater treatment, developing continuous improvement projects focused on water and energy sustainability for clients in Portugal. Welcome, the floor is yours.
Thank you so much, João, for the introduction. I really want to thank you all, especially for Tecnicelpa, for this opportunity to be here and presenting this case. So I will present you the Cooling Horizon 2030. It's a strategy aligned with the Green Up strategy of Veolia related to the cooling systems. How many of you have a cooling tower in your plant? Come on, go ahead. Yeah. In the pulp and paper, we have a lot of cooling towers. It's really a water demand industry, and we need the cooling towers to dissipate the heat produced in the process, for example, in the digesters, in the dryings. So it's really, really important to have it optimized. Like here Henderson says, the cooling sector must act not to ensure low carbon cooling growth. And the solutions really are available today. Why is that so important? Let's see this video.
Some regions of the world are arid, increasingly arid.
Today, this vital resource is under greater pressure than ever before.
The facts are clear. We are not just approaching a global water crisis, we are already living it.
Future wars are going to be fought over who has access to fresh water.
Faced with climate change and resource scarcity, to protect populations and support industries.
According to the United Nations, global water demand is projected to surpass supply by 40% by 2030.
Water, first of all, it cuts across the entire economy. There's no sector that doesn't use water.
It is crucial to ensure access to and availability of fresh water.
Water is humanity's lifeblood. From the food we eat to the ecosystems and biodiversity that enrich our world, to our health hygiene, and survival itself.
While the majority of our planet is covered with water, 97% of this water is salty, and 25% of regions most exposed to extreme drought have direct access to the sea.
It is up to us to try everything we can to preserve these amazing and beautiful resources for generations to come.
So it's really important to save water. That's one of the main goals that we will talk. Do you know that Iberia is considered to be in extremely high to high water stress level by 2050? This means that we need to act now. We need to move forward to treat our systems in a more sustainable way. This is our purpose to Cooling Horizon 2030. Beyond conventional cooling water treatment, we are offering a comprehensive, integrated approach to support you on your sustainability and net zero path. It's a unique and integrated approach based in three main pillars. Chemical solutions with different types of chemicals, it is inhibitors or even biocide stabilizers. The second pillar is the digital. We need to move forward in the digital, and of course, our expertise. Now let's see this in action. This is a case study, a real case with a real customer, a Northern European plant that will remain anonymous for the purpose of this event. Let's see how was their circuit. They had a cooling tower with 1,300 cubic meters, and these are all the data with the recirculation date, flow, concentration cycles of 4.7, that is not so bad for a cooling systems. We know that in pulp and paper mills, we could have cooling towers, especially the process cooling towers with really lower concentration cycles. This means that we are using much more fresh water. And the limited of this circuit was the calcium hardness with 400 till 500 ppm of calcium hardness. So this is basically what I was saying. They were doing a treatment, a one-drum treatment. It means that the inhibitor and the dispersant, it's only in one product. And they had a demand to reduce the phosphate levels in the discharge effluent plant. But they were limited also on the concentration cycles by calcium hardness, as I told before. How did we manage? First, we made several simulations. Let's say if this works. Okay. So we made several simulations. Here in this graph, you can see the evolution of the temperature with the saturation of calcite, calcium carbonate with the concentration cycles on the cooling tower, and with no treatment, it's completely a risk even to put this water in the system because it will scale all the system. With the previous treatment they had, we see that we could go further in the concentration cycles or in the cooling tower, but with some risk if there is some failure in the circuit. If they are top capacity, there is a risk of even at 4.7 cycles, concentration cycles, to scale some part of the circuit. But with the ecofilm treatment, we could go even further with minimized risk for the circuit. So we moved from 4.7 cycles to 6 cycles of concentration, leading to 6% of water saving, makeup water saving, approaching with the ecofilm treatment in the first phase, and also in the second phase, we replaced the biocide enhancer by the technology, the inhibitor HIP 1500, that it's a bleach stabilizer. It's not a biocide, it's not a biodispersant, it's a bleach stabilizer. And it's being dosed on a proportion for each 5 ppm of sodium hypochlorite, we are dosing 1 ppm of HIP. How did we control it? Well, all the control that it's possible, and it's under the best practice for cooling systems. So we control the corrosion, monitoring the coupons. We control all the water quality parameters, the cycles of concentration, of course, the phosphate levels, the AOX formation, and the makeup water consumption. Also, we control some system performance indicators, like the approach temperature in the main heat exchangers and visual inspection on it, and of course, all the microbiologic control, like Legionella, that we know that it's really a peak in the cooling systems, and general bacteria. And how were our results? 40,000 cubic meters of water saved annually just by increasing the cycles in the cooling system from 4.7 to 6. 40% of AOX reduction. And this reduction is related to the less need of dosage of sodium hypochlorite, because as the HIP is a stabilizer of the bleach, what we see is that we needed to dose much less sodium hypochlorite to maintain our microbiology under control, and this leads also to less stripping in the cooling tower, and with this stabilization we have an excellent performance of sodium hypochlorite as biocide, even until pH 10. And also, we reached to 7% less of phosphate levels. You may ask, why not 100%? Yes, we reach actually 100% in the blowdown of the cooling tower, but this plant had another effluents coming from other parts of the plant that they had phosphate. So in total, the discharge from the plant, it represented 70% of reduction in phosphate levels. In terms of the corrosion, we saw a reduction of corrosion higher than 50% for copper, complying completely with the KPI demanded for the plant, and also an excellent performance for the milled steel with a measure lower than 1 MPI, that it's an excellent level for industry. So what about for your systems? What can you gain with the application of these two single products? For the EcoFilm, that is basically a film formation product that takes care of the corrosion inhibition and also the dispersant, it covers all the pain points that you could have in your system, reducing the operational risk, the total cost, the compliance with environmental regulations. We know that in Europe we are moving further in terms of phosphate levels of discharge. This is a no-phosphate, no-zinc product in this formulation. it really allows us to go further in terms of concentration cycles in the cooling towers, and it allows us to work with more stressed waters. This is what I just told. In terms of value, we could have really TCO savings in water, labor, chemicals, and fines. Just remarking that all of these products are really easy to use. They are all traced, and it's really simplified to monitor. In terms of environmental footprint, as I said, no phosphate, no zinc. We know that the phosphate is a nutrient for microbiologic growth. So even in this part, it will help in our cooling systems to have it under control. Reduce water consumption, energy, and in terms of health and safety, reduce analysis and labor time. What about the heap? We cover all the same points in terms of operation, compliance, water, and energy. As I told, it's a bleach stabilizer, 100% biodegradable. It must be dosed together with the bleach. And it reduces the bleach aggressiveness when you're thinking in terms of our metals, our equipment, because as the bleach is stabilized, it is like a target delivery for biomass, for biofilm. You will have less chlorides in the system. So for the cooling towers that you have limited in terms of concentration cycles because of chlorides, with this solution, you can go even further. And of course, it reduced the generation of AOX related to the sodium hypochlorides that you are dosing. The value: reduced consumption, optimized disinfection, reduced operating costs, and longer access protection. And it's really, in terms of environmental, a reduced CO2 footprint. No danger, and it's easy to set and track. Just to present you the other pillar, the digital, I will present you just a small image, a graph. This is a demo related to a real case already, because we see the chemicals, but we need to look also how we are operating, how we are working with our cooling towers. This platform, the inside, with the CTP is the cooling tower performance. We take all the information from your system, and if there is some data missing, we tell you what is missing, and we model it in order to see how you're performing. And from the image number 1, the one in the left, you see that the cooling tower is performing above what it would be supposed to deliver the efficiency that we wanted. And just regulating the fan's velocity, we were able to move to the line that we wanted, saving a lot of energy. This is about the CTP. These are some other graphs of information that we can take. We can go even further to optimize your cooling system. It's about to measure, assure, secure, trend, evaluate, and regulate everything: fans, pumps, chemicals, and operations. This is the cooling horizon based on these 3 pillars. And to finalize, just to present you the conclusion of this. I believe that our questions will be taken now at the end. Just remember that for any type of questions, even if you want to go further on these chemicals or in the digital solutions that we have, you can reach out to us in the stand number 4 of Tecnicelpa. And remember, Iberia will stand to extremely high to high water stress by 2050. We need to act now. Let's deliver a better place for future generations. Thank you.
Well done. Okay, Liliane, well done in fact. I was about to dance with the music, but okay, I cannot do that because I'm here. Okay, gentlemen and ladies, we have about time for 25 to 30 questions from the audience. 1 or 2. Okay, so let's start. Who is the first one? Don't be shy. I know that you are hungry, that you want to go to have lunch, but okay, please start at least. Okay, I will start here with a very difficult question to Inês. It's not really a question, but I have to ask you that. Why did you drill the tree?
Because it's easier test to do to our compare it to the traditional process. This test was made for me and other colleague, so as you can imagine, it's easier for us to drill the tree compared to the traditional process. Yes.
Okay. Okay, thank you. Any more questions from the audience? Well, you are really hungry. Okay, I have another one. Good.
I have one question to the first speaker. Do you have an idea how your additives will affect the processability of the resins during the process of California production? Because organic cations and ferromions are critical for the production of California.
Professor, can you tell it again, because it was not quite clear here. Sorry.
Okay. My question is, do you have an idea what is the consequences of addition of your stimulants on the processability of the resin, especially for the production of California, because as we know, organic cations and especially ferrum ions are critical.
So we did, as you can see, we did the gas chromatography, and we compared the chemical composition for the resin samples that we collected, and the difference, it's not visible. So we thought that it's not a difference between in the composition of the resin and the each fractions of the resin. I don't know if I answer.
Okay. Any further questions? Okay. During the time you think, I have a new one. So this one is for Raquel. You talk about in future applications for what you are doing, but what are now the applications for this non-woven material? So these non-wovens can be, how can they compare with the existing products on the market? Because we have to think about it, what we do of our research, what comes next. So what comes next?
Your research in the lab scale yet, but I think is the materials with higher mechanical properties and we can apply it to many sectors, for example, automotive sectors, and so on.
Thank you. I will move. You have to hear me. You don't ask questions, how I ask questions. We move to Filipa and Joana. I don't buy the water, but by the way. But anyway, how is the end? 80% recycling, 90%. How far can we go? It's a simple question.
Yes, we don't have the final value right now, but at this moment we have the project that I said in the presentation, and we are going to recover around 20% of the total freshwater consumption in the complex, around 20%.
Okay. Quite a good value.
And then we will do again new balances, new characterizations, and try to reach more than it, with or without reverse osmosis.
Okay, thank you. So, last question, and now you can have lunch, not before. So, a difficult question for Liliana. It's really a difficult question. So, when we talk about this new system, these new products, we at the companies, we look always at a difficult issue that is value for money. If I have to spend some capex of the company to buy something new, what is really the value for money that we can take from your presentation?
Is the sustainability, basically. Because as I said, you can go further within your circuits, you save water. Not only the water that you're saving as makeup water, but you're also blowing down less water. It's less water that you need to treat in your effluent treatment in your wastewater plant, okay? And all the energy associated to this. And also, I'm not going to the time life of your equipments, because all of these technologies are really the best in class in terms of corrosion control, dispersion, and microbiology control.
Okay. Thank you, and an applause for this presentation. Thank you very much to you all.